Today we're going to talk about angles and probably triangles. But before we do that, can anybody tell me what they remember about shapes? Ooh, lots of you know things about shapes. Okay, let's start with Talon. What do you remember about shapes?
Shapes of edges.
Okay, good. Lilia?
Polygons.
They're polygons. Very good. Adara?
Some have corners and vertices, some others don't, like the circle or the sphere.
Good. Excellent. Did everybody hear what Adara said?
Yeah.
Okay. Mark.
The shapes that have four sides, like a square, are called quadrilaterals.
Oh, great. That's a good thing you remembered. Okay, Aislinn?
That polygons have to have straight sides. They can't go like have three straight sides and then their fourth one can just go like diagonally.
So are you saying they have to be closed?
Yeah, they have to be closed.
Okay. Aspen?
Some shapes are 3D shapes.
Yes. They are. Some are three-dimensional. That's what we mean. That's what D means, right? Does everybody understand D is for dimensional?
Yeah.
Okay. All right. You guys have a good idea of what shapes are. So we're going to talk about angles and rays and right angles. Well, does anybody know what a ray is? What do you think, Mark? You forgot?
Okay.
Maya?
An array is rows and columns.
That's right. An array is rows and columns. But I'm talking about a single ray. Adara? I'm going to show you what array is. So, because I think you're getting it stuck in your head about an array, and this is just a single ray. And an array looks like this. Now that you see what array is, can you define it? What do you think, Dan? It has an endpoint.
It goes one direction.
And it goes one direction. How long does it go for that one direction? How long? Like, does it just stop or does it go on forever, Ariel?
Go on forever.
It does go on forever. So, everybody, array is a line that has an endpoint and then goes on forever in the direction. Can everybody say that? Array is a line with an endpoint and then continues forever in a direction. Okay, good. So, an angle. Somebody mentioned vertices. Does anybody know what an angle is? Rylan? It has a sharp edge. Okay. Talon? Two edges meet? You're getting close. So close. Amber?
Two line sections, like the end point,
Mm-hmm.
and they come together.
Mm-hmm. They meet together. You're right. An angle is where two lines meet at the same endpoint. An angle is where two lines meet at the same endpoint. Will you all say that with me? An angle is where two lines meet at the same endpoint. Excellent. So would this be an angle?
No.
No, why not?
They're not meeting.
Mark?
Because it isn't connected, they're separated.
Very good. They're separated. So you're absolutely correct about that. Now, we're going to talk about a right angle. What is a right angle? Oh, lots of you know what a right angle is. Okay, Britton.
It goes like that and that.
Okay.
Make a square.
To make a square. So I know what I think I know what you're saying, Britton. Where it goes out and then where its endpoint is, it comes straight down. And where the angle comes together, it makes a square?
Yeah.
Yeah. Do you see the square, guys?
Yeah.
Everybody knew what a right angle was? Well, that's awesome. I'm very impressed. All right, so the difference in an array, or in an angle, sorry, is the difference is the rotation of the two-point angle. So we have a right angle. Is this a right angle? Okay. And is this smaller than a right angle? Is this bigger than a right angle, larger?
Yeah.
It is, very good. So, just for a moment. So now we have two angles. It's like this, and one's like this. Which one is the smaller angle? Aislinn?
The top one.
The top one is the smaller angle. And why is that?
Because it's closing more and then the other one is opening more.
That's right. So the closer it is, the smaller the angle. Excellent. The larger it is, the larger the
Angle.
Okay. So we can classify angles as smaller than a right angle or larger than a right angle. So if it's smaller than a right angle, the correct math terminology is it is acute. What is a smaller angle called?
Acute.
Acute. Smaller than what are we talking about here? Smaller than a large angle or a right angle?
Right.
Right angle. Very good. Now, everybody has two sets of straws, right? And we're going to make angles with those wonderful straws. What are we going to know about these sets of straws? We're calling them rays. We're going to call these rays, okay? What do they share? They're an endpoint. They're an angle. So what do they share at the end?
Endpoint.
Yay! I gave you a hint. End point. Yes. Okay, so now it's your turn. Your turn to make some smaller than right angles and larger than right angles. Look at the rotation. Remember, the rotation is how many turns away from the right angle part it is. Is it smaller or is it larger? I'm out of the range of my camera. I have to turn this thing around a little bit. Okay, show me. Show me your angles. Everybody make one that's smaller. Smaller than a right angle. This looks good. Looks good, Ariel. Very good there, Caleb. That's nice too, James. Okay. Okay, I see a great right angle and a great small angle. And what did we say a small angle was called in mathematical terms? Say it again, real loud, Talon. Acute. Everybody, what's a smaller angle than right angle? Acute. If you know, if you take a piece of paper or a ruler and you put it on your angle, well, your paper's square, right? The end of your paper, the corner of your paper. If it goes out beyond your paper, then you know it's an obtuse angle. What's an obtuse angle? Mariah?
A larger angle.
A larger than a right angle. All right, what did you notice about the triangles besides in the right angles? The yellow triangles? Somebody noticed some things. What did you notice, Kyler and Caitlin? What did you tell me you could do with those triangles? You could make squares.
And also, the squares can make the squares.
The right angles? Yes. And that was very good observation. Observing. Man, I'm tired. This is what happens when you get sick. So, Jaden, what did you notice about any of your other triangles that you and Mark did together? What did you guys notice?
For number 6, we did L, and then we just found out that it looked like a right angle.
It does look like a right angle? Why do you think it looks like a right
Because
angle?
it's that, and then you can make it easily square.
How?
Like you draw an L, and then you can put a square right there, and it looks like a right angle.
You think so, huh?
Uh-huh.
Would you put your paper in the corner and see if that works? Take your card.
The letter L in it.
Oh, the letter L. Oh, the letter L. Yes.
Yeah.
Somebody else noticed that too. Who else noticed that? That's right. So the L, if you make a regular L, makes what kind of angle?
Right angle.
Excellent, excellent. So, I'm out of camera range again. So, were there any other observations made in, say, the orange? What's up, Trevin? What you got? What do you want to share?
I thought it's so squishy.
Oh, because it looks so small, it must be smaller, right? Did you try your card test and see if that would support your findings? Check it out. So, let's put it on. Is that smaller than a 90-degree angle? You don't know? Is it beyond the paper? Did it go way beyond the paper? Yeah. What if I did it this way? Yeah, right? So that's why I said use your cards. They're perfect for measuring on these books, right? And you can determine with this how you're going to know if it's bigger or smaller than a right angle. So see how it extends beyond it, no matter which direction I put it. Now, yes, these guys are smaller. Why? What can you tell me about an obtuse triangle? What's going to be, we're going to have one large angle, larger than 90-degree angle. What are the other two angles going to be? What do you think, Caleb? Okay. Maya? Everybody take your card. Everybody get your card. Okay. Put it on your angle, your obtuse angle. And do you see how one side goes out? And if I do it to this side, the other side goes way out, right? But if I do it to this guy, what happens to the angle? We're not looking at this part, we're just looking at this angle. Where does it go? It goes in or under the paper, right? So we said that makes what kind of an angle? Acute, or smaller than 90-degree angle. What about this guy? We do it with this one. Is that the same thing? Is it?
Yeah.
So what did we say that angle is going to be? Acute. Smaller than 90 degrees. Very good, you guys. So what can we say based on those observations? What can we say about an obtuse triangle? Britain?
It can be an L.
That would be a right angle. Okay. Mark, and based on what we just talked about at the board. Okay, Amber?
Obtuse can have acute angle.
Yep. How many acute angles would an obtuse angle have, Aspen? Okay, go ahead, tell me what you got.
An obtuse is bigger than a right angle.
It is, excellent. And if we have an obtuse triangle, what are the other angles gonna be? Lily?
Acute.
Cute. And did we prove that already? How did we prove it? Talon?
Paper on it, and it goes over the paper to turn cute.
Mm-hmm. And we did it here, and it's acute. And if I did it here, is it still acute?
Yeah.
If I do it here, is it still acute?
Yeah.
Okay, so what can you say and sum it up? An obtuse triangle has one larger than 90-degree angle and two acute angles. But an acute triangle has how many acute angles? An acute triangle has how many? Adara? 3. That's right. Good job. Okay, Talon.
So, even though it doesn't have all the same angles, all the triangles at least have 3 angles.
That's right. So a triangle has how many sides? 1, 2, 3. It has how many angles? 1, 2, 3. Triangle. Remember what somebody said? Tri means 3 and there's 3 angles. That was talent. Let's wrap it up.
And you can also.
We have to wrap it up. A smaller than a 90-degree angle is called an
Acute.
A larger than 90-degree angle is called a obtuse. All triangles have at least 2
Acute angles.
acute angles are
Smaller than a right angle.
excellent. You guys did great. What did you think of your lesson today?
Yeah.
All right, thank you. All right, we're